So today we're going to look at the graph of a rational function and its transformations around the graph. So here's the parent function, y equals 1 over x. You can see that I have it in purple, and I'm going to transform my functions in red. First, let's do the asymptotes. So this function has two asymptotes, a horizontal asymptote and a vertical asymptote. The horizontal asymptote is the equation y equals 0. Let me change that. So it might seem counterintuitive that the x-axis has an equation of y equals 0. But if you look, the y coordinate everywhere on the x-axis is 0. So no matter where we are on this line, the y value is 0, which is why it is the line y equals 0. The x value is, the vertical asymptote is the equation x equals 0. And similarly to the x-axis, everywhere we go on the y-axis, the x value is 0. And that's why the equation is x equals 0. Now we're going to look at what happens if we change the parameters h and k in the function. How does it transform from the original, the parent function, the purple, to be a new graph? First, let's see what happens when we change k. As we change the value of k, you can see that the function is moving up, or if k were to be negative, the function is moving down. So you can see how the purple changes to the red just by moving up or down. The vertical asymptote is not changing at all, just the horizontal asymptote. Look at how the horizontal asymptote changes. If k were to be 2, the horizontal asymptote y equals, if we slide it up, we can see that it fits right in there at 2. So whatever the k value is equal to the horizontal asymptote y equals. So we could actually just say in general, y equals k gives us the horizontal asymptote. And as we move k up and down, you see the horizontal asymptote changes in exactly the same way. Let's go back to making k 0 and see what happens for h. So as h gets larger and larger, positive, we see that our graph moves to the right. And as h goes into the negatives, our graph moves to the left. Let's set h at -5. We can see that the horizontal asymptote hasn't changed now, just the vertical asymptote. That's the x equals. So let's slide our vertical asymptote over, and we can see that it matches. When h is -5, our vertical asymptote is also at -5. So in general, we could say that x equals h gives us our vertical asymptote. Don't forget that h is being subtracted here. So if you were actually see this in an equation, it would look just a little different. You would have y equals 1 over x minus -5. And that might actually be written as y equals 1 over x plus 5, since subtracting a negative is the same as addition. As you can see, all these match. So you have to be careful when you're looking for h to know that it's the opposite sign of what you might see in the equation. Finally, we know that we can move h and k. We don't just have to use one or the other, and it will move the graph both left and right and up and down. So in this scenario, we have a horizontal asymptote at 2, a vertical asymptote at, let's change it from -5 to maybe -3. And let's just write that equation so we know what to do. That equation would be y equals 1 over, it would be x plus 3, since we moved to the left 3, but we're subtracting -3, which makes it addition. And then we would add 2 so that the graph can move up by 2.